So hi to you watching this video. So for this video, we're going to discuss about friction. So in the preceding modules, when we were solving problems, the surfaces of contact between two bodies were considered to be perfectly smooth. Okay, and because of this, the force of interaction between two bodies or bodies always acted normal to the surface at points of contact. But in reality, that is not the case because we have friction. Okay? So friction forces are present through nature and exist in all machines no matter how accurately constructed or carefully lubricated. So there is no such thing as frictionless. There will always be the presence of friction. So a machine or process in which friction is small enough to be neglected is said to be ideal. When friction must be taken into account, the machine or process is termed real. Okay? If it is frictionless, it is ideal. When there is the presence of friction, it is termed the real. Okay? Makatotohanan. So in this module, equilibrium of various rigid bodies and structures, assuming dry friction at the surface of contact will be discussed. Also, several specific engineering applications where dry friction plays an important role. So we have wedges or wedge, square threaded screws, journal bearings, thrust bearings, rolling resistance, and belt friction are explored. Okay? So at the end of this module, you should be able to solve problems involving friction, equilibrium, and friction. Okay? So we're going to relate uh, friction in equilibrium. So, so by definition, friction may be defined as force of resistance acting on a body which prevents or inhibits any possible slipping of the body. So it is a resistive force. Pinipigilan niya, nire-resist niya yung possible na pag-slip or pagdulas ng isang body. The force always acts tangent to the surface at points or it is perpendicular, okay, to the point of contact with other bodies and is directed so as to oppose the possible or existing motion of the body at these points. So what are the types of friction? Number one, you have the dry friction. Number two, you have fluid friction. So contacting surface are separated by film fluid, either gas or liquid. And number three, you have internal friction. So what is a dry friction? So dry friction exists when unlubricated surface of two solids or rigid bodies are in contact under conditions of sliding or tendency to slide. Okay, so dry friction, it does not involve any lubrication. So if there is a tendency for the body to slide or a condition of sliding, so it is known as the column friction. Since its characteristics were extensively studied by CA in 1781. Okay, so the theory of friction. So considering a block of mass m, so you have here a mass m resisting on a rough horizontal floor and the effects that are caused by pulling horizontally by a force P. So you have here a mass and it is being pulled by a force P as shown in the free body diagram. So the floor exerts a normal force. So you will have here a normal force on the free body diagram here, and the pulling force P will be resisted by the frictional force. Okay? Remember that the normal force is always perpendicular to the contact surface. So since this is the contact surface, normal would be perpendicular. And the frictional force is opposite the direction of the pulling force. Since the pulling force is towards right, the frictional force is towards left. And the resultant force of N or of N and F is R with angle alpha. Okay? So we have here a graph for the dry friction. Okay? So you have here when a motion is involved, we have a static friction and we have a kinetic friction. It is static when the body is not moving, but there is a presence of unbalanced for there is a presence of force, but it is still in its equilibrium. Okay, so the graph in Figure 5.1 shows that as the magnitude of the pulling force is slowly increased from zero, the magnitude of the friction force increases. So hanggang tumataas yung pulling force na P, it is linear in such a way that the frictional force is also increasing. Okay? In such a way that it will attain a maximum value of static friction called the limiting static frictional force. Ibig sabihin, pag na-reach na natin yung limiting static friction force at this point, your mass or your body will start to move. And from static friction, it will now be kinetic friction. Kinetic friction, ibig sabihin, it is already in motion. Okay? So, experimentally, it has been established that the magnitude of limiting static friction or force is directly proportional to the magnitude of the resultant of the normal force. So, F is directly proportional to N. Therefore, the static frictional force is equivalent to the constant mu of S or the friction coefficient of static friction times the normal force. Okay? So, if it is a moving body, force is directly proportional to the normal force. The kinetic force is equivalent to the coefficient of the kinetic friction times the normal force. Okay? Ibig sabihin, yung body natin or yung mass is already moving. Okay? So next we have the angle of friction. The angle of friction is the angle that being made by the normal and the frictional force. It is the angle of the resultant of these two forces. Okay? So, the friction force F and the normal force N are components of the total reaction exerted by the plane surface upon the block. So, this is your reaction, okay, of the surface. So this is your frictional force, this is your normal force. Normal force perpendicular to the contact surface. Frictional force is opposite the pulling or pushing force. If F is 0, this angle will be 0, definitely. If F increases, so does the angle increases. The particular value of this angle when maximum frictional resistance is acting is defined as the angle of friction. It acts at its maximum value of phi only when motion is impending. So tangent theta, so you have here tangent phi is equivalent to opposite, that is F. Frictional force divided by the adjacent, which is the normal force. So tangent phi is equivalent to F over N. Therefore, the coefficient of static friction is equivalent to tangent of phi S. In other words, the tangent of the angle of friction is equal to the coefficient of friction. When motion impends, the angle of inclination determines the angle of friction. So we consider coplanar forces. In order for motion not to occur, static reaction R must lie with the angle ABC. So this is AB. Where is C? Anyways, whereas For problems involving non-coplanar forces, it must be contained within the cone generated, revolving around AB, about the normal BN. The cone so formed is called the cone of friction. So this is your cone of friction. No, for the for this figure, it is the cone of friction. Equilibrium range of the line of action of R. Okay, so we are now ready to solve our problems. So we have here problem number 1. A 400 block resting on a rough horizontal surface for which the coefficient of friction is 0.4. Determine the force P required to cause motion to impede if applied block A horizontally, B downward at 30 degrees with the horizontal, and C what minimum force is required to start motion. Okay, so we have here letter A, P if applied horizontally. Okay, so first we need to draw our free body diagram. So what are the forces that would be present? So we have here a weight of 400 pounds. So that is a downward force. Okay. So next we have here the unknown, which is P. And we also have here the normal force. Always remember that the normal force is perpendicular with the surface. So it is perpendicular with the contact surface. Therefore, this is my normal force. And since P is towards right, the frictional force is opposite. Therefore, it is pointing to the left direction. So this is my frictional force. And we are given the coefficient of static friction, which is 0.4. Okay, so we can now solve our unknown. Isn't it that from our discussion, we know that tangent phi, or angle of friction, is equivalent to mu. Okay, this case, our mu is mu of s. Therefore, tangent phi is equivalent to 0.4. Therefore, phi is equivalent to arctangent of 0.4. Therefore, angle of friction is equivalent to 21.80 degrees. Okay? 21.80 degrees. So we can now solve for our P. Okay? So summation of forces horizontal is equivalent to 0. All forces that are pointing towards right should be positive. So we have here P minus F is equivalent to 0. Okay? So that we have one unknown, but we know that F is equivalent to mu of n. So we need to solve for the value of n in order to solve for the value of F. So we will be using summation of forces. Summation of forces vertical is equivalent to 0. All forces that are pointing upwards should be positive. So what are those forces? So we have negative 400 plus n is equivalent to 0. Therefore, n is equivalent to 400 pounds. Then we can now solve for the value of F. F, therefore, is equivalent to 0.4 times 400. And that is equivalent to 160 pounds. Then from there, we can now solve for our P. Okay? So, this is our equation 1, this is our equation 2. So, substitute F, substitute F in 1. So, P minus the value of F, 160 pounds, is equivalent to 0. P therefore is equivalent to 160 pounds. Okay? You can also use the force triangle. Okay? So, saan manggagaling yung force triangle? Where is it coming from? So, we have here W. It is pointing downwards. Then we also have here the resultant force. The resultant force here. This is your resultant force. And take note, we have here angle phi, or the angle of friction. Therefore, this is also phi. And we will be having here the resultant. No, this will be having here P. And this is 400. Okay? So we can simply use tangent. Okay? So tangent phi is equivalent to P over 400. Cross multiply 400, P is equivalent to 400 tangent phi. We know that tangent phi is equivalent to mu of S. Okay, so that is 0.4. So P is 400 times 0.4. Therefore, P is equivalent to 160 pounds. Okay, next we have letter B. So for letter B, P is applied downward at 30 degrees with the horizontal. So we have here the block, and what are the forces present? Okay, so we have here the W, it is pointing downwards. We also have here the this is the contact surface, so we'll be having here the normal force in, and we have here the frictional force. So since the horizontal force of this P is towards right, therefore the frictional force is towards left. That is F, but F is equivalent to mu of N. Okay, so that's the forces that are present. So we have in order to solve for P, we can use the force triangle, or we can use the equilibrium. So for equilibrium, summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So for P, it is sine. Okay? So P sine 30, P sine 30 minus, that is pointing downwards, minus 400 plus N is equivalent to 0. So this is my first equation. Okay? Next, summation of forces horizontal is equivalent to 0. All forces that are pointing towards right should be positive. So for the horizontal component of P, it is cosine. So P cosine 30, it is pointing towards right, assumed to be direction is towards right, so that is positive. Minus F, and F is equivalent to mu of N, and mu is equivalent to 0.4 times N is equivalent to 0. Okay, so this is my second equation. So we simplify the value of, we simplify N, so transpose this to the other side of the equation to make it positive. So 0.4 N is equivalent to P cosine 30. Cross multiply, N is equivalent to P cosine 30 over 0.4. Substitute in there. Then we can now solve for the value of P. So we have here sub N in 1. So negative P sine 30 minus 400 plus P cosine 30 divided by 0.4 is equivalent to 0. Or you can simply use your calculator to solve your equation. Okay, so simultaneous equation, then you can now solve it. But since we already simplified it, let's solve na. Negative alpha x sine 30 minus 400 plus alpha x cosine 30 over 0.4 is equivalent to 0. And that is equivalent to 240. 240.23 pounds. And that is the value of P. If we want to use the triangle, we can do so. Okay, so we have here the W. So we have here W of 400, And we also have here the P. Okay, so for the P, it is pointing downwards. Okay, and the resultant would be this. This would be the resultant. The angle here is same as the angle here. So that is what's the angle? 21.80 degrees. The angle here is equivalent to 9. Take note that this is a 90 this is 90 degrees, and that the angle here is 30 degrees, so the angle here is also 30 degrees. Therefore, the total angle here is equivalent to 120 degrees. Okay, so in order to solve for the angle here, we know that the angle of the interior angle of a triangle is 180 degrees. So minus 21.80 minus 120 degrees, and that is equivalent to 38.2 degrees. So using sine law, we can have sine 21.80 over this is P. This is this is P. So that is P over P is equivalent to sine of angle here, and that is 38.2. So this is 38.2. Sine 38.2 is to 400. Okay, so sine 21.8 over P is equivalent to P is equivalent to 240.21 pounds. They should be the same. Okay, almost equal. Next is the minimum force to start motion. Okay, so we have here the 400-pound block, and this would be the weight. And since this is the contact surface, we will be having here the normal force. And okay, so a force required to start this block in motion would be a force P at an inclined angle of the angle of friction. Okay, so we have here the frictional force as well. So this is F, and that is equivalent to mu of N. And we also have here the resultant force. The resultant here, this is R, inclined at an angle of phi from the vertical. Okay, and we also have here P inclined at an angle of the vertical, and we know that that is the angle of friction. We can solve it via force triangle or via equilibrium. Okay, so let's try equilibrium. So summation of force is vertical. All forces that are pointing upward should be positive. So we have here negative 400 pointing downwards, and we have here positive N pointing upwards, and we have P. The vertical component of P is sine phi. Okay, so plus P sine phi is equivalent to 0. So substituting the value of sine, we have negative 400 plus N plus plus P sine, and the angle there is equivalent to wait 21.80 degrees, and that is equivalent to 0. So we have two unknowns. Okay, so next we have the summation of forces horizontal. So summation of forces horizontal is equivalent to 0. All forces that are pointing towards left should be positive. So P, the horizontal component of P, is cosine. So P cosine 21.80 minus F, and F is mu of N, minus mu of n, and that is equivalent to 0 0.4. 0.4 n is equivalent to 0. Okay, so substituting the value in terms of p, transpose this to the other side of the equation, that is 0.4 n is equivalent to p cosine 21.81, and therefore is equivalent to p cosine 21.81 divided by 0.4. So substituting, we have here, this is my equation 1. So we have sub n in 1. So negative 400 plus the value of n, we have p cosine 21.81 divided by 0.4 plus p sine 21.80 equals 0. Okay, so we have here negative 400 plus alpha x cosine 21.81 divided by 0.4 plus alpha x sine 21.8 is equivalent to 0. And p therefore is equivalent to 148.57 pounds. Okay, next, using the triangle, we will be having here, this is p and this is r, and we have here the weight. The weight is 400 pounds. Okay, so what are the angles involved? Okay, so the angle involved here, this is phi. So if I am to draw a plane here, the angle also here would be phi. So this is angle phi. Okay, so how are we going to solve for p? Take note that the angle here is with respect to the horizontal is phi. The angle here with respect to the vertical is phi. Therefore, the angle here, or the angle between them, is 90 degrees. It is a perpendicular forces. So P and R are perpendicular forces. That is to determine, and kaya rin tayo nag-angle of inclination here, because the perpendicular distance will give us the maximum, the minimum value of P. Okay, so we have here P. So how are we going to solve for P? By using sine function. Okay, so sine 21.81 degrees is equivalent to P over 400. P therefore is equivalent to 400 sine 21.81, and it should be the same. P is equivalent to 148.61 pounds. They should be almost be equal. Okay, we have here number 2. So body A and body E are joined by a cord parallel to the incline. So this is the cord. Under body A, 200 pounds with a mu of 0.2, while 0.5 for body B, and it is weighing 300 pounds. Determine the angle theta which motion impedes. What is then the tension in the cord? So we need to determine the angle here and the force, the tension force in the cord. Okay, so first we need to draw our free body diagram. Okay, so this is for block A. So what are the forces present? So the forces present, we have here WA is equivalent to 200 pounds. And the normal force, take note, is perpendicular to the plane. So this is normal A, and the angle that it makes with the vertical is equivalent to, okay, that is an unknown yet. Next would be the frictional force. Take note that we have a tensile force here, and the tensile force is towards north uh, northeast. Therefore, our friction force should be, or it should be the same direction as this or opposite. Take note that this is the frictional force. This is the no, this is the tension force, and this tension force is pulling this block that is falling. Okay, so nahuhulog siya. It is towards this way. Therefore, since the block here is downward, the frictional force is opposite. Okay, so ibig sabihin, the frictional force is parallel with our T. Okay, this is F, and F is equivalent to mu of N. Okay, so that is our free body diagram there. Okay, if we are to draw our Cartesian plane, the angle here is theta. The angle also here is theta, because the angle here is theta. Okay, so let's start with A. For the free body diagram of A, FBD of A. So for the free body diagram of A, summation of forces is equivalent to 0. All forces that are pointing northwest should be positive. So what are those forces? So we have NA, and we have WA, and it is cosine. Okay? So 200, it is, but it is pointing downwards. So ito 'yon. That is the 200. So minus 200 cosine theta is equivalent to 0. So that is my first equation. We can simplify this further. NA is equivalent to 200 cosine theta. This is my first equation. Next, summation of forces towards that direction. Okay, so summation of forces, let's say this is y prime, this is x prime, is equivalent to 0. All forces that are pointing this way are to be positive. So what are those forces? So we have f of n, that is mu. What is mu? For A, that is 0.2. So 0.2 of NA plus T. Then for WA, it is minus 200 sine theta is equivalent to 0. Okay, so substituting the value of N, so sub NA in, let's say this is equation 2. So we have 0.2 NA. What is NA? 200. 0.2 NA, that is 200 cosine theta plus T minus 200 sine theta is equivalent to 0. Okay, 0.2 times 200 is 40. So we have here 40 cosine theta plus T minus 200 sine theta. Okay, so let's say that this is my equation number 3, equivalent to 0. This is my equation number 3. Next would be the free body diagram of B. So what are the forces present? Okay, so here the tension is upward, here the tension would be downwards. Okay, it is pointing that way. Then we have here the weight, which is 300 pounds. Then we are to draw our Cartesian plane. We have here the angle theta. we have here the normal force as well, perpendicular to the contact surface. So this is NB. Then the angle also here is equivalent to theta. Okay, so we have here T. So for the free body diagram of B, so FBD of B is equivalent to summation of forces, let's say y prime. Summation of forces y prime is equivalent to 0. All forces that are pointing towards that direction should be positive. So what are those forces? So we have negative T minus 300 sine. Okay? 300 sine. So we have here minus 300 sine theta. And that's it for, yeah, that's it, equivalent to 0. Next would be summation of force. No, this is x prime. This should be y mali, wrong direction. So that's the direction. Okay, next, summation of forces. X prime is equivalent to 0. Then all of the forces towards that direction should be positive. Though this, no, this is erroneous. FBD of B, no, nalito tayo sa direction. So we have here so summation of forces y prime is equivalent to 0. So all forces pointing that direction should be positive. So we have positive NB. So NB, and this one is cosine of 300 pointing downward, so that is negative. So 300 cosine theta is equivalent to 0. Next, summation of forces x prime is equivalent to 0. All forces that are pointing towards that direction should be positive. So we have negative T, and we have here F. Take note, for F, it is still upwards. Okay, because this one is will be sliding downward, therefore the frictional force will be towards up. Okay, so plus F is mu of n, plus F, and F is mu. What is mu for B? It is 0.5. So 0.5 n is equivalent to plus minus 300 sine theta is equivalent to 0. This is NB. So transpose these two terms to the other side of the equation to make it positive, or we can simply substitute here the value of N and B. NB is 300 cosine theta. So negative T plus 0.5, the value of NB, that is 300 cosine theta, minus 300 sine theta is equivalent to 0. So we have here T, and T in terms of T, so we can solve for the theta. Okay, so transpose this to the other side of the equation. T is equivalent to, what is 0.5? 0.5 of 300, that's 150. So 150 cosine theta plus 300 sine theta. Let's say that this is my equation number 4. So substitute 4. So substitute 4 in 3. So substituting, we have 40 cosine theta plus, what is the value of T? 150 cosine theta plus 300 sine theta minus 200 sine theta is equivalent to 0. So we can now solve for theta. 40 cosine theta plus 150 cosine theta plus 300 sine theta minus 200 sine theta. Theta therefore is equivalent to 100. This value is too high for this angle, the angle here, so there might be there is an error. So let's check. So transpose this, that becomes positive, positive, minus. So we have here an error. So the sign here should be minus. Okay, so this should be minus. Okay, so 40 plus 150, that is 190 cosine theta, and this is equivalent to negative 500 sine theta, and that is equivalent to 0. So solving it would be 560.807 degrees. So how are we going to determine the angle theta? So from here we have a complete a one revolution is equivalent to 360 degrees. So we're going back here. So 560, so 560 minus 360 degrees, so minus 360, then minus 180, half revolution is 180 degrees, minus 180, that is 20.81. Therefore from the vertical going to the northwest is theta. Therefore theta is equivalent to 20.81 degrees. Okay, since that is theta, we all know that this is also theta, and since this is also theta, the angle here is also theta. Therefore theta is equivalent to 21.81 degrees. We can now solve for the value of t. So for the value of t, it is 150 cosine 20.81 minus 300 sine no 81 minus 300 sine 20.81 degrees, and that is equivalent to 33.63 pounds. Okay, next we have here number 3, a horizontal bar 10 feet long and negligible weight. So this is the bar, rest on rough inclined planes as shown in the figure. If the angle of friction is 15 degrees, how close to B may the 200 pounds force be applied before the motion impinges? Okay, so gaano kalayo yung 200 pounds from support B before this this plane will be moving this way. Okay, so we have to draw our free body diagram first. So this is the point of contact. We'll be having here a normal force perpendicular to the plane. Therefore, this is NA. Next would be NB, perpendicular to the plane. Now, take note that if this 200-pound force is being applied, depending on the distance from B, the motion would be this way. Okay, so on point A, it is going up. Therefore, the friction force is opposite in the direction. It is going down. So this is F of A. Next, for B, it is going down. Therefore, the friction force is going up. Okay, so this is my F of B. Okay, so if we are to determine the resultant, it would be for A, this would be the resultant. This is 15 degrees. For B, the resultant would be here. Okay, so this is 15 degrees. So we need to determine the reaction of A and B first. Okay, so this is reaction A and this would be reaction B. So take note, the angle here is 60 degrees. The angle here is 30 degrees. So we have two unknowns here. We have RA and RB. So using the equation of equilibrium, summation of forces horizontal is equivalent to 0. All forces that are pointing to the right should be positive. So for the horizontal component, take note, if we are to draw our triangle, this would look like this is the resultant here. Okay, and that is the 90 degree. Ayusin natin. It should look like this because we're looking for the horizontal. Now for the angle, take note, this is 30 degrees here. This is 30 degrees and this is 15 degrees. So for the RA horizontal, it is sine opposite over hypotenuse. So that is RA sine 45 degrees. Next for RB, it would look like this. So this is for the horizontal. It is this is 30 degrees as no. This is 60 degrees here because it is perpendicular to this. This is 60 degrees, therefore this is also 60 degrees, but I only need this angle. So the angle here would be 60 minus 15, that is 45. So that is also sine minus RB sine 45 degrees is equivalent to 0. Sine will cancel out. Transpose this to the other side of the equation to make it positive. Therefore, RA is equivalent to RB. Okay? Next would be the vertical. Summation of forces vertical is equivalent to 0. All forces that are pointing upwards are positive. So what are those forces? We have here, okay, take note, the vertical is acting on this side. Dito yung vertical natin. So that is cosine. This is 30 degrees plus 15, that is 45. So RA cosine 45. Then here we have the vertical here, and the angle here is also 45, so that is also positive, pointing upwards, plus RB cosine 45 minus 100 minus 200 is equivalent to 0. So we have here RA is equivalent to RB, so this is also equivalent to RA. Okay, so substituting, we have 2 RB cosine 45 minus 300 is equivalent to 0. So we can now solve for RB. So 2 alpha x cosine 45 minus 300 is equivalent to 0. Therefore, RB is equivalent to 212.13, and this is in pounds. Why did I solve for RB? Because I'll be having my moment at A. Then I can now solve for the value or for the distance of x. Okay, so summation of moment with respect to A is equivalent to 0. All forces that are rotating clockwise should be positive. So we have 100 rotating clockwise with a lever arm of 2 minus, we have 200, or plus rather, because it is also clockwise, plus 200 times a distance of 10 meters minus the distance of x. So that is 10 minus x plus FB, minus RB rather. RB rotating counterclockwise. So RB, and RB is 212 minus 212.13 times a lever arm of 10, and that is equivalent to 0. Therefore, x is equivalent to 100 times 2 plus 200 times alpha x, 10 minus alpha x minus 212.13 times 10 is equivalent to 0. Therefore, x, wait, there's something lacking. Take note that the 212.13 here is RB, but we need the vertical component. So for the vertical component, we multiply this by cosine 45. Okay, so this is 45 degrees cosine. Okay, so we have here 100 times 2 plus 200 alpha x minus 10 minus 212.13 times 10 times cosine 45 is equivalent to 0. Okay. Baliktad. So that is minus alpha x. Okay. Therefore, x is equivalent to 3.5 feet from B. Okay. So that is from B. And that is the final answer. Okay, so we have here problem number 4, a homogeneous cylinder, 3 feet in diameter, so diameter is 3 feet, and weigh 400 pounds is resting on two rough inclined surfaces as shown. So on the left side it is 45 degrees inclination, and on the right side it is 60-degree inclination. If the angle of friction is 15 degrees and the couple C applied to the cylinder, that will start it rotating clockwise. Okay, so this is the cylinder. It will rotate in a clockwise manner. So this is the contact surface. So since this is the contact surface, it will create a normal force perpendicular to the contact surface. Okay, and likewise with this one. Okay, so let's say this is NA, this is NB. Okay, now for the frictional force, let us analyze how is our force behaving, or the direction of our force behaving. So here it is rotating clockwise, therefore the frictional force is opposite in direction, so it would be downwards. Okay, so this would be F. So this would be FA. Here it is downwards, therefore FB would be upwards. Okay, so that is FB. Therefore, this would be the resultant. This is RA, and for RB it will be located here, and the frictional force is 15 degrees. So this is 15 degrees, and this is also 15 degrees. Okay, and we have here the weight. The weight is equivalent to 400 pounds. So for this problem, there are two ways of solving it again. First, we can have the force triangle, or we can use the equilibrium equations. So summation, if we're going to use the equilibrium equations, we will be having summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So what are those forces? We have negative 400 since it is pointing downwards. Next, since this is the resultant for RA, okay, so that is the resultant for RA. If we are to draw a Cartesian here and a Cartesian here, the angle here is the same as the angle here, so that is 45. So the total angle here is 45 plus 15. Okay? No. Yeah, tama. That's 45, because that is 45. 45 plus 15, the total angle here is 60 degrees. Okay? So this is the horizontal component. while this is the vertical component. Now for the horizontal component for the B, we have here the horizontal and this is the vertical. Now for the angle here, take note that the angle here is 60 degrees and the angle here is also 60 degrees. But we are only up to this point. Therefore, the total angle here is 45 degrees. Okay? So, for the vertical component of RA is pointing upwards. Therefore, it is positive. So, plus RA, and that is a cosine function adjacent over hypotenuse. So, that is RA cosine 60. Next, we have RB. Again, it is positive because it is pointing upwards. Plus RB cosine 45 degrees. And that is equivalent to 0. Okay? So, that is my this is my first equation. Second equation would be summation of forces horizontal is equivalent to 0. All forces that are pointing towards right would be positive. So what are those forces? We have RA. RA for the horizontal, it is sine function. So we have RA sine 60 degrees minus RB. RB is towards left. Okay. So that is sine function again, but it is minus. So RB sine 45 degrees. And that is equivalent to 0. So transpose this to the other side of the equation to make it positive. Okay. So RA sine 60 is equivalent to RB sine 45. RA therefore is equivalent to RB sine 45 divided by sine 60. So substituting the value of RA to our first equation, we have, so let's say this is equation 1, this is equation 2. So sub 2 in equation 1. So we have negative 400 plus RA, substitute RA, we have RB sine 45 over sine 60 times cosine 60 plus RB cosine 45, and that is equivalent to 0. Okay, so solving for that, we have negative 400 plus alpha x sine 45 divided by sine 60 times cosine 60 plus alpha x cosine 45 is equivalent to 0. Therefore, RB is equivalent to 358.63 pounds. Okay. Next, solving for RA, substitute this to RA. Therefore, RA is equivalent to 358.63 times sine 45 divided by sine 60 is equivalent to 292.82 pounds. And that is the value of RA and RB. But that is not the unknown. Take note, we are to find the couple C. So when we say couple, we have a moment at C. That is the one that is causing the rotation. Okay? Or, yeah, the rotation here. So we need to determine what is C. Find the couple applied to the cylinder. To the cylinder. So this one, not at the center. Not to the center specifically, but to the cylinder. Okay. So in order to do that, we will be using moment. Okay. So summation of moment with respect to, let's say, at the center. Let's say this is O. O is equivalent to 0. All forces rotating clockwise should be positive. So what are those forces? So we have here C, and it is rotating clockwise. Next, 400 is concurrent with O. Therefore, we can simply cancel that out. For this one, for the inclined NB, if we are to uh, determine the line of action, NB will cancel out because it is also concurrent. Likewise with NA. Okay, so we are left with FA and FB. Okay, take note that F is equivalent to mu times N. Okay, but we do not know the value of N. But we can solve for N. But there's a faster way of solving. We can use this small triangle here. Okay, so if I am to redraw that here, let's say I'm going to redraw that here. This is N A, then this is the frictional force. This is the frictional force there. That is FA. And this is the resultant. That is the resultant. F, and if I'm to redraw that here, that is still FA. Okay, so that is still FA with an angle of 15 degrees. So I can create a right triangle. So solving for FA, it is sine 15 over the hypotenuse of R. Okay? So from there, we will be having, but FA is rotating in a counterclockwise, therefore it is negative. So FA is sine 15, which is opposite. So that is sine 15 opposite FA over R, o RA. Cross multiply, magiging ganito yung equation natin. RA is 292.82 sine 15 degrees times the lever arm. What is the lever arm of FA? The lever arm of FA is the radius. What is the radius? It is 1.5. Okay? Next would be the FB. FB here is also rotating in a counterclockwise manner. Or is it clockwise? It is counter. So we have here FB. So if I'm to redraw that here, it would look like this. So this is NB. So that is NB there. Then we have here FA, which is pointing upwards. Therefore, the resultant is this one. Okay, so if I'm to draw here, if I to transfer that here, it would look like this. So I can create another right triangle. This is FB. Okay, so for FB, it is sine 15 degrees opposite over the hypotenuse, and we have RB. RB here. What is RB? It is 358.63. So FB is rotating counterclockwise, therefore it is negative. Negative FB, that is opposite sine 15. Sine 15 is equivalent to FB over the hypotenuse of RB. Cross multiply, that would be RB sine 15, and RB is 358. So minus 358.63. Sine 15 is equivalent times a lever arm. What is the lever arm between FB and O? That is the radius. Times 1.5 is equivalent to 0. So solving for the value of C, we have sine 15 times 1.5. Equate it to 0. Then we now have the value of C. C therefore is equivalent to 252.91 pound feet. And this is the final answer. Okay. As I've said a while ago, we can solve this RA and RB using the force triangle. Okay. So if you want to use the force triangle, you can do so. We have here the weight of 400. We have here R and we have here RB, and we have here RA. Okay. Then we have here the angles. What are the angles? The angle that RB makes with the vertical is 45 degrees. Take note, this angle here is 45 degrees. The angle that RA makes with the vertical here is also 60 degrees. Okay, so the internal angle of a triangle is 180. So that is 180 minus 70, minus 60 minus 45. Therefore, the angle here is 75 degrees. So using sine law, we can solve for RA and RB. So for RA, sine 45, we have RA over sine. Opposite side or of opposite angle of RA is 45. So sine 45 is equivalent to, we have 400 over sine 75. Therefore, RA is equivalent to sine 45 292.82 pounds. Lastly, we have RB, so we use the opposite angle of sine of 60. So that is RB over sine 60 is equivalent to 400 over the opposite angle of sine 75. Definitely it should be the same, 358. But let's try to input that in our calculator. Sine 60 is equivalent to 400 over sine 75. We have 358.63 pounds. So they should be the same. Okay, so we have here problem number 5. In the figure, two blocks are separated by a uniform strut attached to each block with frictionless pins. Block A weighs 500 pounds, Block B weighs 300 pounds, and the strut AB weighs 200 pounds. If the mu is 0.25 under B, determine the minimum coefficient of friction under a to prevent motion. Okay, so we have here block A. This is block A. This is block B, and this is your strut. The weight at block A is 400 pounds. The weight at block B is 300 pounds. So let's label that. This is 400 pounds. This is 300 pounds. And we have the strut, which is 200 pounds. Of course, it is acting at the center of gravity of the material. Now, the mu on B is equivalent to 0.25. Okay, so we need to determine the minimum coefficient of friction under A to prevent the motion. Okay, so we need to determine the coefficient here in order that this body here will not move. Okay, so how are we going to do that? First, we need to determine the vertical and horizontal component of the reaction on point A and point B that is being produced by the 200 pounds. Then we will incorporate that in the strut. Then after no in the block B, then from block B we can now solve the coefficient of friction at block A. Okay, so I repeat, magsimula tayo sa strut, then kung ano yung effect ng 200 pounds dito sa block A, sa block B, madedetermine natin. And pag na-determine natin yung block B, reaction at block B, we can now determine the reaction at block A, then it will lead us to solving the coefficient at A. Okay? So, first, we need to label what are the components sa strut. So, we have here, let's say this is A horizontal, this is A vertical, this is B horizontal, and this would be B vertical. Okay? So with that, we can use the equations of equilibrium. So for the free body diagram of strut, we can have the summation of forces. Summation of forces vertical is equivalent to 0. All forces that are pointing upwards should be positive. So what are those forces? Okay? So we have here 400 pounds pointing downward, so that is negative. Negative for, no. We are still on the strut, so that is negative 200, the weight of the strut. Then we have A vertical plus A vertical minus B vertical is equivalent to 0. Okay? But by observation, we can say that B vertical should be upwards because we only have 200 pound force and it is acting at the center. So this 200 pounds will be carried by A vertical and B vertical. Therefore, my first assumption is incorrect. It should be pointed upwards. A vertical plus B vertical is equivalent to, transpose this to the other side of the equation to make it positive, that becomes 200. Okay? Again, by observation, we know that this 200 pound is acting at the center of the gravity. Okay? Center of the gravity of this body. Therefore, by observation and by symmetry, we can say that A vertical and B vertical will be carrying 200 pounds, half of the 200 pounds. So that would become A vertical is equivalent to B vertical. Okay? So from this equation, we can say that 2A vertical is equivalent to 200. Therefore, A vertical is equivalent to 100 is equivalent to B vertical. Now, for the horizontal, summation of forces horizontal is equivalent to 0. All forces that are pointing towards right should be positive. So, what are those forces? We have A horizontal minus B horizontal is equivalent to 0. Therefore, A horizontal is equivalent to B horizontal. Okay? So, that's it. Okay, so we are now going to use the force triangle. Okay, so for the free body diagram of B, FBD of B, we have here FBD of B. So how is that going to look like? We have here at point B, let's say this is BX. Okay, this force here is BX, and the force here is, let's say, AX. Okay, so for that, we will be using now the force triangle. We have here the 300 pounds. Which is the weight of block B. Plus, we also have another 100 pounds, which is here Take note here, B vertical is pointing downward. So if I am to transfer the load here, it will be pointing downward. So that is 100 pounds downward. Okay, so we will add here another 100 pounds that is pointing downward. Next would be the RB. Okay, so this is RB. So RB, we have it here. So this is RB, and we also have here BX. Okay, so this is BX. Okay, so what are the angles involved? So the angle here is 60 degrees. So if I'm to make it to make the angle here with respect to here, it will also create a 60-degree angle. Okay, so the angle here is 60 degrees. Okay, so how about the angle here? Take note, the angle here. Take note, this is no, no. Then this is my resultant. Okay, so this is a 15-degree angle for the friction coefficient for the angle of friction. Now this is 60 degrees, so therefore this angle here is 60 degrees. But the angle here, no, this is not 15 degrees, rather. The angle here is less than 60 degrees. So let's say this is theta. What is theta? So tangent theta is equivalent to the coefficient at B. What is the coefficient of friction at B? So it is 0.25. So tangent theta is 0.25. Therefore, theta is equivalent to the arctangent of 0.25. And theta is equivalent to 14.04 degrees. Therefore, the angle here is 60 minus 14.04. Okay? So 60 minus 14.04, that is equivalent to 45.96 degrees. Okay? So the angle here is 45.96 degrees. Then the angle here is the interior angle of a triangle is 180. So 180 minus 60 minus 45.96, and that is equivalent to 74.04 degrees. Okay, so what we are looking here, or what we need to solve here, is not the B. What we need to solve here is the BX. Because if we can have BX, we can solve for AX. And if we can solve for AX, definitely we can now solve for mu of A. Okay? So, if we are to do that, take note, this is 300, this is 100. We have one side, we have an angle. We have an angle, we have missing side. So, we are going to use the sine law. Okay? Using sine law, we have bx over sine 45.96 is equivalent to this side. We have 400 divided by sine 74.04. Okay, so bx therefore is equivalent to 299.07 pounds. Okay, so by inspection, okay, we can say that bx is equivalent to ax. Why did I say so? If you're going to go back here for the strut, a vertical is the same as b vertical. A horizontal is the same as the B horizontal. But if you're having a doubt, you can do you can use the two equations of equilibrium, summation of forces vertical and summation of forces horizontal. But likewise, you will still arrive at the same answer for AX, which is 299.07 pounds. Okay, so that is to ease from us from another lengthy solution. Okay, so we can proceed with block A now. So here, take note, for the A vertical, you have an for the strut, A vertical is downward. If I am to transfer that here in the strut, we will be having 100, which is pointing downwards. Okay, so we can now proceed with our block A. So we have here this is NA, this is FA, which is mu times NA. Okay, so we need to solve first for NA before we can solve for mu. For mu. Yes, for mu. Okay, so how are we going to do that? By using the summation of forces vertical. So this is FBD of A. Summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So what are those forces? We have negative 400 minus 100 plus, we have here plus NA. And AX is pointing downwards, okay? So for the vertical component of AX, take note that this angle here is 30 degrees. And the vertical component is a sine function. So that is minus sine 30 is equivalent to AX vertical over the hypotenuse. And the hypotenuse is 299. So 299.07. And that is equivalent to 1, 2, 3. So tama. That is equivalent to 0. So NA is equivalent to negative 400 minus 100 plus alpha x minus 299.07 sine 30 is equivalent to 0. And that is equivalent to 649.54 pounds. So we can now solve for our mu of A. Summation of forces horizontal is equivalent to 0. All forces that are pointing to the right should be positive. Take note, FA here is pointing to the right because what we are trying to prevent is the movement of block A towards right, towards left. Therefore, the frictional force is towards right. Okay? So we have here FA. What is FA? It is mu of A times NA, which is 649.54 minus the horizontal component of AX, and that is a cosine function. So 299.07 cosine 30 degrees. Meron pa ba? We have 1, 2. No. Equate this to 0. Therefore, mu of A is equivalent to 0.4. And that is your final answer. So next we have here number 6. Determine the force P required to start the wedge shown in the figure. The angle of friction for all surfaces in contact is 15 degrees. Okay, so the angle of friction at all contact is 15 degrees. So we need to determine this P, that this force P that will cause the block to move. This will move downward, and if this move downwards, this will move towards right. So if we are to solve that, we will solve it backwards. So from here, we are to solve the force here. Then if we can now solve the reaction here, we can solve the reaction backwards towards P. Okay, so if we are to draw the free body diagram, the first thing again that we need to do is to draw the free body diagram. So if this is the block, what are the forces involved? You have the weight 200 pounds. You have the force P. You have the force towards left, which is 500 pounds. And since this is a contact surface, we will be having here a friction force. We will be having here a friction force of towards right. Why is it left rather? Why is it towards left? Because if we are to apply a load force P here, this block here will move downwards, and if this move downwards, this block here will move towards right. Okay, therefore the frictional force will be towards left. Then we have here the normal force, and we have here the resultant 3. Then from there, we have another contact surface at this point here. So we will be having a friction force, and we will be having a normal force. Why is the friction force towards downwards? Rather, kasi if we are to draw our free body diagram this for this block, take note we are to apply a downward force here. So the frictional forces on these two sides here is upwards, since the force here is pointing downwards. Okay, again, since we are applying a force which is downwards on this block, the frictional force which is opposite would be upwards. So if we are to translate this force here, the frictional force here on this block, it is pointing downwards. Okay, then we will be having our normal force here. Then for this side, we have the normal frictional force pointing upwards, and the normal force towards left. Then we have R1, which is this one. Okay, so we are now ready to solve for our unknown. So here, what we only need to do or determine is reaction 2. Because if we can solve the reaction 2 here, then we can solve reaction 1 here. Then, or we can use that reaction 1 here in order for us to solve for P. Okay? So we start with the block. So the free body diagram of the block. So the free body diagram of the block is equivalent to this. Okay, so let's start, let's say vertical. Summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So what are those? We have here the weight of 200 pounds. That is negative since it is pointing downwards. We have R3. And R3 is in terms of cosine, because we need the vertical. So cosine 15 pointing upward, so that is positive. So that is R3 cosine 15. Then we have here R2, and that is pointing downwards. So that is minus R2 sine 15. And 1, 2, 3. So we only have 3. Equate that to 0. Okay. So what I need to solve is R2. So transpose this to the other side of the equation to make it positive. You have R2 sine 15 is equivalent to R3 cosine 15 plus 2 minus still minus 2000. Then cross multiply, we have R2 is equivalent, no, it should be in terms of R3, because I need to solve for R2. I need R2. No. We transpose this to the other side of the equation. We have R3 is equivalent to R2 sine 15 plus 2000. Then cross multiply, we have the denominator as cosine 15. This is R3. And this is my equation number 1. Next, summation of forces horizontal. So summation of forces horizontal is equivalent to 0. All forces that are pointing towards right should be positive. So what are those forces? So we have R2. R2 is towards right, and the horizontal component of R2 is cosine function. Cosine function. Okay, so we have here R2 cosine 15 minus 500 minus R3. The horizontal component of R3 is sine function. So minus R3 sine 15 and equate that to 0. So substitute. So this is my equation 2. So sub 1 in 2. So we have R2 cosine 15 minus 500 minus R3. We have R2 sine 15 plus 200 divided by cosine 15 times sine 15 is equivalent to 0. We can now solve for R2. Sine 15 plus 2,000 divided by cosine 15 times sine 15, and that is equivalent to 0. Therefore, R2 is equivalent to 1,155.39 pounds. Okay, since I already have here R2, I can now use triangle force. So I already have R2, and yeah, I have angles. So we can now solve. Let's draw first our triangle. This is P. So we have here force P. Then we have R2. And this is R1. Okay, so R2. This is R1. The angle here is 15. This is 15 degrees. Okay. The angle here for R2, take note, if I am to draw a Cartesian plane here, the angle here is also 15. This is 15 degrees, so the angle here is also 15 degrees. So the angle that R2 makes with the horizontal is 15 degrees. Therefore, the remaining angle here is 90 minus 15 is 75. Okay, so this is 75 degrees. Next would be the angle here, the R1 that it makes with the vertical. Okay, so take note, the angle here is 15 degrees. So if I am to create a Cartesian plane here, this also the angle also here is 15 degrees. Okay, so this frictional force here and the normal force is 90 degrees. So the angle between them, so the angle here is equivalent to 90 minus 15 minus 15. Therefore, that is equivalent to 60 degrees. The angle here is 60 degrees. And the angle here is equivalent to the total angle of the interior angle the total angle of a triangle is 180 minus 60 minus 75, and that is equivalent to 45 degrees. So we can now solve for the value of P. We have R2. R2 is equivalent to 1155.39 pounds. We have a known side, known angle. We have a known angle, unknown side. So we use the sine law. Okay? And that is equivalent to, we have here P over sine 45 is equivalent to the known side, which is 1155.39 over the unknown, over the known side, known angle. We have sine 60. Therefore, P is equivalent to sine 45 is equivalent to 1155.39 divided by sine 60. Shift solve. P is equivalent to 943.37 pounds. And that is the value of P. Next we have here is belt friction. So the theory of column friction can also be used to analyze the forces acting between a flexible body. So flexible body in such a way that it can be a rope or belt and a friction surface. So if the tension on one side of the belt is known, the following equation can be used to calculate the belt tension in the other side. So for example, this is your rope or this is your belt and it is acting on a surface. Of course, definitely it has a friction and one of which is unknown. Therefore, we can solve for one side or the other side using this equation. T2 over T1 is equivalent to E raised to mu times beta, where E is equivalent to 2.718, and that is the base of natural logarithm. Okay? The beta here is the angle between the contact surface or the contact or of the rope which is in contact with the surface, and that is this one. Okay? So we need to keep in mind this following guidelines. T2 is the belt tension that is directed opposite the belt friction. Therefore, T2 must always refer to the larger of these two tension. It is opposite the tension. It is opposite the belt friction. Therefore, it is larger. Next, for impeding motion, mu is equivalent to mu of s, or the static coefficient of friction. If there is relative motion between the belt and cylinder, use mu is equivalent to mu k, or the kinetic coefficient of friction. The angle of contact, beta, must be expressed in radians. I repeat, angle must be in radians. Because the equation is independent of the radius r, its use is not restricted to circular contact surfaces. It may also be used for a surface or arbitrary shape. Okay? So with that in mind, we can now proceed with our example. Okay, so we have here the example for belt friction. So in the figure, the coefficient of friction is 0.2 between the rope and the fixed drum and between all the surface in contact. So between the rope and the fixed drum is 0.2, the coefficient of friction. Likewise, with the surface in contact. So this is 0.2 and this is again 0.2. Determine the minimum weight to prevent downplane motion of the 100,000 pound body. So when the 100,000 pound body is sliding this inclined plane. So in order to prevent that, what is the desired minimum weight that we need to apply to prevent the sliding of this 1,000 pounds? Okay, so the first thing that we need to do is to draw our free body diagram. So this would be the free body diagram of the drum. So you have here a tensile force and another tensile force. Then we have here the free body diagram of the 1,000 pounds and the free body diagram of the weight that we need to apply. Okay, so for the first thing that we need to do is to draw the free body diagram of the 1,000 pounds. So this is the 1,000 pound inclined at 3 versus 4 slope. Okay, And we need to identify our friction forces. So what are the friction forces? Take note that this 1,000 pound is sliding downwards. Okay, therefore the friction forces you have here for FB, the friction forces are uh, sliding up. Okay, it is opposite the direction of the motion. Okay, so which of these two is the TB? Take note that TB is the largest value. Okay, so here it would be uh, the one connected with the 1,000 pounds. Why? Because take note that this 1,000 pounds is the one that we are trying to resist in sliding down, and this drum with a friction of 0.2 will help us prevent the sliding of this drum, which is having a weight of W, which we are trying to determine. Therefore, of these two ropes, the TB is the one connected with the 1,000 pounds. Okay, that would be my TB. And this one, TA, would be the one connected with the with the W. Okay, kasi mas maliit yung weight na i-carry ni W compared sa weight or sa tensile force ni na i-carry, which is connected to TB. Okay, so this would be my TB. So since this is TB, it is a tensile force, and we have here a 1,000 pound weight connected. Take note that at the contact surface we have a normal force. So we have here the normal force NB, and here we have the normal force NA. Okay, so we are now complete with our 1,000 pounds. Next would be the weight, okay, that we are looking for. So this would be the weight. Next, since on the 1,000 pound block, FA is upward, therefore if we are to translate it on the W block, it is downwards. Okay, opposite direction, opposite in direction. Then we have a contact surface, therefore we have a normal force, which is NA. Then we have a tensile force TA. Okay, then I will assign that my y-axis would be inclined, and my x-axis would also be inclined, so that it would be easier to solve. Because if I will assign my y-axis to be vertical and my x-axis to be horizontal, it would be difficult to solve. Because every now and then, ang hahanapan natin ng horizontal and vertical component would be NA, NA, FA, FB, and B. But if we're going to orient our y-axis this way and x-axis this way, it would only be the W and the 1,000 pounds. So that would be a lot easier. Okay, so we can now start solving by determining our equations. Okay, for this problem, we will be having multiple equations. So let's start with the free body diagram of the drum. So we have here the FBD of the fixed drum. So we have here TB and this is TA. Okay, so TB over TA is equivalent to E raised to mu times beta. So substituting the value of mu, TB is equivalent to cross multiply. We have TA times E raised to mu, which is 0.2, and for the beta it is 180 degrees, and 180 degrees is equivalent to pi in radian. So we have here 0.2 times 180 degrees, because if we're going to check it here, the contact surface is 180 degrees. So 180 times we have is equivalent to 180 degrees is equivalent to pi. So 180 degrees would simply cancel out. Therefore, we are going to be left with pi. Okay, so TB is equivalent to alpha E raised to 0.2 times pi, and that is equivalent to 1.874 TA, and this is my equation number 1. Okay, so next would be for block 1000 block. So we have here the free body diagram of 1000 pound block. Okay, so summation of forces along the y-axis is equivalent to 0. All forces that are pointing towards northwest would be positive. So what are those forces? So we have here, wait, let me adjust my camera. Okay, so all forces directed toward northwest are positive. So what are those forces? We have, since we are on block 1000 block, so we have negative NA, so negative NA, then we have positive NB plus NB, then we also have here the 1000 pounds. So take note here, the slope of the incline is 4/3, therefore the slope here would be the inverse. That would become 4. This now becomes 3 in the square and the hypotenuse of 5. Okay, so minus 1000, because it is pointing downwards, minus 1000 times the y component of the slope, which is 4 over the hypotenuse of 5, and 1 2 3 wala na, and that is equivalent to 0. Okay, so this is my equation number 2. Next, summation of forces along the x-axis is equivalent to 0. All forces towards northeast are positive. So what are those forces? So we have FA. FA is equivalent to 0.2 NA. Okay, tama. So FA is 0.2 NA. FB is 0.2 NB. So plus 0.2 NB plus TB. Then we have the horizontal component of the 1000, or the x component of the 1000, and that is minus 1000 times the horizontal component of 3 over 5, and that is equivalent to 0. Okay, so this is my equation number 3. Next would be the free body diagram, the FBD of W. Okay, so the FBD of W. So summation of forces along the y-axis is equivalent to 0. All forces that are towards northwest should be positive. So what are those? We have here positive NA, and we have negative W. And again, they have the same slope as the 1000 pounds. So this is 4, this is 3, and the hypotenuse is 5. Okay, so positive NA minus W times the vertical component of 4 over 5 is equivalent to 0. Okay, so transpose this to the other side of the equation to make it positive. NA is equivalent to 0.8 W. Okay, but if you are to check your equation from the equation 1, 2, and 3, we do not have here W. So what I'm going to do is W in terms of NA. So I can solve for NA and NB. Okay, so W therefore is equivalent to 1 divided by 0.8, and that is 1.25. So W is 1.25 of NA. So this is my equation number 4. Okay, next, summation of forces along x-axis is equivalent to 0. All forces that are towards north west are to be positive. So what are those forces? So we have here FA. FA is directed opposite the positive. So that is 0.2 NA, that is negative, plus TA, minus the horizontal component of W. And that is W times 3 over 5 is equivalent to 0. Okay, so this is my equation number 5. But take note, we have EW here, and we have an equation for W. So substituting, we will be having negative 0.2 NA plus TA minus what is W? Minus 1.25 times 3 over 5 is equivalent to 0. Okay? So, NA. We have here NA is equivalent to 0. So, negative 0.2 minus 1.25 times 3 over 5, that is negative 0.95. So, negative 0.95 NA plus TA is equivalent to 0. Therefore, TA is equivalent to 0.95 NA. So, from equation 1, this is now my new equation number 5. Okay? So, there you have TA. And if you're going to check here, the common unknowns would be NB, NA, TB. So, here, you have TB is equivalent to 1.874 of TA. And you can have it here. You will be having here TA. So, it will be in terms of NA na. Okay? So, what I'm going to do is substitute 5 in 1. So, we have here sub 5 in equation number 1. And what is equation number 1? Equation number 1. TB is equivalent to 1.874 TA. Substitute TA. So, TB is equivalent to 0.95 times NA. What is NA? NA. Yeah, tama. NA times TA. No, that's already TA. Wait, nalito ako. So, mali. So, TB, correction. TB is equivalent to 1.874 times TA, and TA is 0.95 NA. Therefore, TB is equivalent to 1.874 times 0.95 is equivalent to 1.7803, and that is NA. Okay, so this is my equation number 6. So that is TB. So, if I am to substitute TB here on my third equation, I will be left with NA and NB only. Okay, so if that will be the case, I will now have two equations left, this one and this one. Then I can solve for NA and NB. So, substitute equation number 6 in equation number 3. So, equation number 3 is 0.2 NA plus 0.2 NB plus TB. What is TB? 1.7803 NA minus, what is 1,000 times 3 over 5? That is 600 is equivalent to 0. So, combine similar terms, 0.2 plus 1.7803, that is 1.9. So, we have 1.9803 NA plus 0.2 NB minus 600 is equivalent to 0. So, this is now my equation 7. Okay. So, solve equation 2 and 7 simultaneously. Then we can now solve for NA. So, we have here negative Na plus Nb minus 800 is equivalent to 0. Then we have here 1.9803 Na plus 0.2 Nb minus 600 is equivalent to 0. So it's easier if we're going to input that in our calculator. Solve simultaneously two unknowns. So we have negative 1, 1, 800. Then we have 1.9803. Then we have 0.2. Then we have 600. Na is equivalent to 201.81 pounds, while Nb is equivalent to 1001.81 pounds. Okay, so where can we find an equation where we can substitute Na in order to solve for Nb? And that is equation number 4. So substitute Na in equation number 4. So W is equivalent to 1.25 Na, and that is equivalent to 1.25 times 201.81. W therefore is equivalent to 1.25 times 201.81 is equivalent to 252.62 pounds. And that is the final answer for the W, in order to resist the sliding of this 1,000 pound here. Okay.